Hello, welcome back dear students. Today is the last video of the module number 5 of organic chemistry, that is carboxylic acid and sulfonic acids. We had a very detailed discussion of carboxylic acid in the previous classes, and today it's a very short discussion of sulfonic acids. You know that sulfonic acid is a rare kind of functional group which we come across. It is SO3H. This is the group. It can be conducted to alkyl or aryl group. So it can be alkyl sulfonic acid or aryl sulfonic acid. We'll be discussing the structure, preparation and properties of sulfonic acids. Before we go into the details, first of all, let us make it clear about the structure of sulfonic acid group and compare it with sulfuric acid, the common amino acid. Sulfuric acid is H2SO4. It is a dibasic acid, that means it has two OH groups, right? Now in sulfonic acid, what happens? One OH is replaced by alkyl or aryl group, correct? Now it is a monobasic acid. Remember, sulfonic acid is the most acidic organic compound, more acidic than carboxylic acid. Its acidity is comparable to sulfuric acid, right? Now, two more structures we will make clear. One is chlorosulfonic acid, which we will come across in the discussion. It's a good reagent for sulfonation. What is chlorosulfonic acid? Instead of this, if it is Cl, it is chlorosulfonic acid, right? ClSO3H, chlorosulfonic acid. Another compound we see is sulfonyl chloride. What is it? You have here alkyl, this one, you consider this one. Instead of OH, you keep Cl, then it is RSO2Cl. That is what is alkyl sulfonyl chloride or aryl sulfonyl chloride. Okay, so we have three kinds of structures in the discussion. Now, coming to the name, nomenclature. In IUPAC system, the suffix used is sulfonic acid itself. Since this group doesn't contain any carbon, it cannot come part of the main chain or parent name. So the name is explicitly shown. So what is the name here? One carbon, so it's methane sulfonic acid. Wherever required, give positions. The next one, this is a chain. This is 3 carbon propane. 1, 2, 3. So what is the name? Propane 2 sulfonic acid. The common name will be isopropyl sulfonic acid. This one is aromatic, benzene sulfonic acid. This one, position, this is having highest priority functional group. This is 4. So 4 amino sulfonic acid, or it can be commonly called parasulfonylic acid. That's a common name. Sulfonylic acid, that is combination of aniline and sulfonic acid, that's sulfonylic acid. Okay, that's about the name. Now coming to preparation, various methods of preparation of sulfonic acids. Actually, you have learned already this thing in your 4th sum organic chemistry. Sulfonic acid is prepared right from benzene. Sulfonation agents can be different. You can use either, generally we use fuming sulfuric acid for sulfonation, right? You remember that? H2SO4 rich in SO3, so it will be fuming. Together it is H2S2O7, so you can call it oleum also. Okay. You need only 50 degrees Celsius for sulfonation using fuming sulfuric acid. you get sulfonic acid. Reaction can be simply shown like this. C6H5, H, this H is replaced here, isn't it? It's one of the characteristic electrophilic aromatic substitution reactions of benzene. H replaced by SO3 group. So sulfuric acid is the one which is reacting. You can see that water is the byproduct here. You will get H2O, right? You may recall the mechanism of this reaction. Actually, the electrophile is which one? SO3, isn't it? That's the one, the electrophile which is attacking benzene ring. So you may recall the two steps involved in the mechanism. Okay. Now you can also use instead of fuming sulfuric acid, which is stronger reagent, you can also use concentrated sulfuric acid, but at a higher temperature. Then sulfuric acid will undergo, you know, that auto ionization and produce SO3, and the reaction takes place in the same fashion. One important aspect of sulfonation is that it is a reversible reaction. So sulfonation is followed by desulfonation. It's reversible. Another thing is, aromatic compounds easily get sulfonated compared to aliphatic compounds. Okay? Means formation of aryl sulfonic acid is much easier than alkyl sulfonic acid. So sulfonation can be used as a test, an analytical test to distinguish aliphatic and aromatic. That comes in your organic analysis. Now the third option is using, what is this? ClSO3H, chlorosulfonic acid. That also can be used for sulfonation. What will be the difference then? The difference that the byproduct will be what now? It will be HCl instead of this one, H2O. It will be HCl in this case. That's the difference. Okay. Now coming to properties. In properties, one point is regarding melting point. Melting point of sulfonic acid, remember, now onwards we will be discussing about benzene sulfonic acid. That is the important member of this class for our discussion. Okay. Benzene sulfonic acid has a melting point of around 51 degrees Celsius. Compare it with benzoic acid. What is that? We already discussed. Here COOH. It has high melting point. How do you account for this? Anyone? If you compare, benzoic acid is having higher melting point compared to sulfonic acid. Maybe this has a higher molecular mass, still this has higher melting point. That is attributed to the tendency of carboxylic acid or benzoic acid to undergo dimerization through hydrogen bonding. That kind of association is not possible for sulfonic acid. That's the reason. Secondly, solubility. Sulfonic acid is highly soluble in water, naturally because it is quite acidic, ionizable, and so it dissolves well in water. Right. Now we go to the properties. First of all, acidity. I told you sulfonic acid is as strong as sulfuric acid, very strong acid. So if you compare acidity of alcohol, phenol, then carboxylic acid and sulfonic acid, interestingly, acidity increases in this order. Already we discussed this part in detail earlier on, right? With reason why acidity increases in this order. And now sulfonic acid is still more acidic. How do you account for this? For that, let us consider the conjugate base of sulfonic acid, that is SO3 minus alkyl sulfonate anion. Let me write the structure. It will be like this. Okay. This is the conjugate base of sulfonic acid. We know whenever we talk about the acidity, what you do? You consider the stability of the conjugate base. this is clear that it is resonance stabilized because this lone pair is in conjugation with the double bond. So you get another resonance structure. It becomes negative charge here and double bond here, and it can go to this side also, right? So this is greatly resonance stabilized, and resonance stabilization is found to be more than that in carboxylic acid. See, we already learned that carboxylic acid is more acidic than phenol. In both cases there is resonance stabilization, but resonance stabilization is more in carboxylic acid. Why? It has equivalent resonance structures, number one, and it has 2 oxygen to stabilize the negative charge. What about sulfonic acid? Here also you get equivalent structures. Actually you have one more structure. 3 equivalent structures, and also there are 3 oxygen atoms to stabilize the negative charge. So it is more acidic than carboxylic acid. So sulfonic acid react with, for example, if you treat with sodium bicarbonate or sodium hydroxide, you get the sodium salt, or SO3Na plus minus plus H2O. If it is bicarbonate, what is the advantage? You know, this is the reagent for testing acidity of carboxylic acids. Likewise here also, it will form the sodium salt, or SO3Na plus minus plus there will be H2O. In addition, there will be CO2. That is the best part of this reaction. You can observe brisk effervescence as an indication of acidity. Fine. Coming to the next, formation of acid derivatives, the next property. See, we learned that carboxylic acid form 4 important types of acid derivatives, like acid halide or chloride, ester, amide, anhydride. Similar thing happens here also. Sulfonic acid also can form corresponding acid derivatives, right? Let's take, for example, let us take benzene sulfonic acid. Okay, if it is treated with SOCl2 or PCl5, what happens? It forms the chloride, acid chloride. So this OH will be replaced by Cl. So what do you get? You get SO2Cl. What's the name of this? I already told you. Benzene sulfonyl chloride. Okay. Plus you will have HCl and SO2. Then if this is heated in presence of P2O5, what is P2O5 for? For dehydration. You can get anhydride. 2 molecules will undergo a condensation. I am writing in short like this. This is pH, phenyl group, SO2, O, SO2, pH. What is this? This is benzene sulfonic acid anhydride, or benzene sulfonic anhydride. So anhydride and chloride is directly produced from sulfonic acid. But the other 2 derivatives which are left out, amide and ester, they are prepared better from the corresponding chloride. So we take benzene sulfonyl chloride, which is more reactive, as you know. To convert it into ester, it is treated with an alcohol. Okay, for example, C2H5OH. Okay, you can use some catalyst base, for example, and you get it as, you get the ester like this, SO2, and this is connected here, HCl with a byproduct, so OC2H5. What's the name of this? Ethyl benzene sulfonate. That's the name. Ethyl benzene sulfonate. Now the last one is, if you treat with ammonia, it's very reactive, you know, it quickly reacts. Simply combine, HCl is lost, it forms amide. What's the name of the product? SO2NH2. What is this called? This is called benzene sulfonamide. Benzene sulfonamide. Okay. So that's the preparation of acid derivatives of sulfonic acid. Now coming to another kind of reaction, that is replacement of SO3H group. See, this SO3H can be easily replaced by various reagents. Okay. That is one advantage of SO3H. It can be easily expelled or substituted. Various reactions. For example, sulfonic acid, if it is heated with in presence of acid, it undergo hydrolysis and produce benzene. So it easily give benzene. That means this is broken HNOH. It is hydrolyzed. Actually, this reminds us about the desulfonation. In the preparation I told you, this preparation is reversible, so this can get reversed. So it is a kind of desulfonation. Now, the next three, you can replace SO3H by either OH, CN or NH2, giving a chance to prepare various compounds by heating with this reagent. But for that, we have to take the sodium salt of sulfonic acid, which is quite reactive or suitable for this reaction. So what you do is, take sulfonic acid, treat with NaOH and make it sodium salt, and then you fuse it. First you are fusing with NaOH. Okay, fusing with NaOH. What happens? This will become phenol. OH will come in place, but since it is NaOH, it will first form the sodium salt. It will not remain as phenol, it will be sodium phenoxide. So you need to add acid to get the product, that is phenol. So converting benzene into phenol, this is a good route. Suppose you have a conversion. Benzene into phenol. You write a question. Convert benzene into phenol. It's not easy. Substituting H by OH. So this is a good route. Change into sulfonic acid. Do sulfonation followed by this reaction. Next is, if you are fusing with NaCN, directly CN will come in place. You get benzonitrile. What about the byproduct here? It's interesting. This will form sodium sulfate. In all cases, you will have Na2SO3 as the byproduct. So this is benzonitrile. If you are treating with NaNH2 sodamide, you will be getting this replaced by NH2. That means you are getting aniline. Very good reactions. Aniline is obtained. Okay. So these are various reactions. See, importance of this reaction is that if you have a question, convert benzene into benzonitrile. Okay. Introducing CN on hydrogen is not, on benzene ring is not easy. So you have a route through sulfonic acid. So first you sulfonate and then treat with respective reagent. And again, this can be converted into two important products. One is by hydrolysis, it can form benzoic acid. So you write a question, convert benzene into benzoic acid. This is a good route. Another one, if you reduce this, what you get? On reduction, what you get? This becomes CH2NH2, that is benzylamine. So that's another question you can write. Convert benzene into benzylamine. So this is a very delicate kind of conversion, right? So these are important reactions of benzene, sulfonic acid. And finally, we have one more reaction, that is, which one? Ring substitution. See, what is that? You consider benzene sulfonic acid. We know that you learned in last year that SO3H is a deactivating group because it is electron withdrawing, highly withdrawing. So it is deactivating, and if at all the reaction takes place, it is meta-directing. So if you carry out nitration of this, it's very difficult because it is deactivating. That means what? Benzene sulfonic acid is less reactive than benzene towards nitration. So you have to use very strong conditions, nitrating mixture at very high temperature. Okay. So nitration takes place. in drastic condition at the meta position. So you get what? Meta-nitrosulfonic acid. Similarly, you can do halogenation using bromine and iron. Okay, you get bromine here. You can sulfonate this again using fuming sulfuric acid or concentrated sulfuric acid, high temperature, or using chlorosulfonic acid. Also, you get sulfonation here. That means you get benzene disulfonic acid or 1,3-disulfonic acid. Okay, so that is the ring substitution of sulfonic acid. It is deactivating and meta-directing. Okay, now finally we have a word on an important reagent, an important compound coming under this head. What is that? Torsil chloride. What is it? Look at this structure. What is the name of this? This is para-toluene, isn't it? With respect to this is para. So para-toluene sulfonyl chloride. I am writing it here. Para-toluene sulfonyl chloride. Okay. Now I am marking here. This is shortly called torsil. How? T-O-S-Y-L. So it is simply called torsil. What is the structure? Like this. You have a para-toluene group, then SO2. I am writing it here. So this is para-toluene sulfonyl and Cl here. So it's a sulfonyl chloride. So this group, this much is torsil. Shortly this is written TSCl, torsil chloride. Okay, why we mention this? The importance of this compound is that, see, in organic synthesis, alcohol is an important class because from alcohol various compounds are synthesized because OH can be substituted with various groups. But the limitation is that when you do substitution reactions of alcohol, the replacement of OH is difficult because OH is not a good leaving group. Because in leaving tendency you have learned that weaker the base, stronger, better the leaving group. OH minus is a strong base, so it's a poor leaving group. So generally what is done, in the reactions of substitution reactions of alcohol, what is done? It is protonated by adding acid. So it becomes like this. Water, H2O. And now it easily breaks. It is a better leaving group. Okay, but acidification again pose some limitations in using the nucleophiles because nucleophiles are generally weak bases. So in acidic medium, reaction become limited in terms of using various nucleophiles. And again, another problem is mostly this reaction takes place via SN1 mechanism, and in SN1 mechanism this form carbocation and it suffer rearrangement. So rearrangement is another limitation of using alcohol as such for substitution reactions. So the way out is convert alcohol into another leaving group which is a better leaving group, and that is torsilate. We convert alcohol, see, alcohol is treated with this compound TSCl, that is torsil chloride. So what happens? Torsil chloride is this, it is Cl, SO2, and you have a benzene ring and CH3, right? So what happens? It will combine here. So it forms a compound that is RO SO2 C6H5 CH3. This is called alkyl torsilate. Alkyl torsilate. What is the advantage of this group? This is a much better leaving group. This easily break. It's a good leaving group. Okay? Because sulfonic acid is a very strong acid, so its conjugate base will be a weak base. Weaker the base, better the leaving group. That's the rule. Weaker the base, better the leaving group. So that is the advantage of this using Torsil chloride, okay, for substitution reactions of alcohol. Okay, that is why we mentioned this compound here. Anyway, one or two words about how it is prepared. Very simple. How you can prepare this Torsil chloride? You take toluene, okay, then you sulfonate it using any of the methods which we mentioned, fuming sulfuric acid. Okay, so what you get? You get sulfonic acid. Of course, you get the para product, which is a major product, and then it is chlorinated using some reagents like SOCl2. It becomes Cl over here, right? That is the method. Or you can use directly. You can use chlorosulfonic acid also for this purpose. At -5 degrees Celsius, chlorosulfonic acid directly form this product as a para product, which is solid. Okay, SO2Cl. You get this Torsil chloride directly using this reagent. Okay, of course you may get some ortho, but here it is that this para product is solid and the ortho product is a liquid. It can be easily separated by filtration. So when you have this torsilate like this, if I write, or I can shortly write like this, ROTS, okay, ROTS. If you are treating with, for example, C2H5ONA, I am talking about the kind of substitution reaction which torsilate undergo. So using this nucleophile can easily replace this, and you get ROC2H5, means you can prepare either. If you use, for example, C2H5OCONA like this nucleophile, you will be getting ester like that. You can prepare various compounds from alcohol via torsilate. Okay, so that's all. See, by using treating Torsil chloride with alcohol, remember pyridine is used maybe to neutralize the HCl form. Fine. So that's all about sulfonic acids. With this we come to end of this module. Thank you.